All right, we're on to the last part of our lecture 15, so part C. All right, so it's going to be more balancing, a little bit different kinds of problems, but more balancing and talking about types of reactions. So before we do that, there's one thing I meant to mention in the last video that I forgot. So let me talk about it right now. You might remember in part B, we looked at these reactions and we figured out the categories they were in. I'm not going to go over that again, right? We already did that. So what I did want to mention though was that often when you write out a reaction, you might see these little S's or AQs after the formulas. So what are those? Why are those there? What does this G mean? What does that mean? Well, what those are, they're telling you like what kind of substance we have. So S stands for solid, like aluminum is a solid. So if you see a little S, that means that the thing is a solid. G means that we got a gas, so hydrogen is a gas, for example. What else do we see on here? Oh, L is a liquid, so bromine is actually a liquid. And then the only other one you'll see on here is AQ. So AQ stands for aqueous. What the heck does that mean? That's a Q there. Aqueous means that it's a solid that has been dissolved in water. That has been dissolved in water. A solid that's been dissolved in water. All right, so you'll see these all the time in reactions. So kind of trying to tell you even more about what the heck is happening in this experiment. All right, so with that, let's move on. And before we try some a little different, let's just go back and let's do one more balancing. All right, so I'm going to do one more regular balancing one. All right, so let me go ahead and write it out. So let's write out a reaction. And let's see if this is making sense to you. I hope it is. All right, Mn plus AO2O3. All right, so what are we supposed to have learned so far? Oh, kind of reactions. All right, so when I look at this kind of reaction, I see a single replacement. Do you see a single replacement? I see a single replacement. Little happy family. Along comes aluminum. Throws out the manganese. Goodbye, manganese, you're all on your own. And then aluminum hooks up with the oxygen instead. So this is a single replacement reaction. All right, what else are we supposed to be learning besides kinds of reactions? We're also supposed to be learning about balancing. All right, so balancing means to get the same number of atoms on both sides. All right, I don't think this thing is balanced right now. Let's double check and let's see how we can get it to balance. So I'm going to make my list. What do I got so far? Left-hand side, I've got one manganese. I've got two oxygens. I've got one aluminum. Right-hand side, I've got one manganese. How many aluminums? Two. How many oxygens? Oh, I switched colors. I don't even know why. How many oxygens? Oh, there's three oxygens. All right. So take a look at that list. I'm just going to take a deep breath. Does that list make sense? How it came up with that list? It's basically just the subscripts, right? Does that list make sense? Okay, I hope it does. Okay. All right, now you can see there's a couple issues. Where we start, it doesn't really matter. We got to fix both problems. There's two problems I see. Who's my problems? Oxygen is one of them, right? That's not matching up. Who's my other problem child? Aluminum. Aluminum's the other problem. So we need to get them both fixed. So the way that we're going to fix them, we're going to put in coefficients. Now, you notice this is sort of something you saw earlier when we were writing formulas. If we look at oxygen right now, the problem I notice is we've got 2 on one side and 3 on the other. So how are you going to get 2 and 3 to match up? Well, the only way to get them to match up, you're going to have to get them both to 6. So you have to find a common number. So to fix oxygen, the only way to get them to match up is to get them both to a common number, which is 6. So how would I get 6? What do I want to put in this first blank? What do I want to put right here? I would have put a 3, wouldn't I? Because 3 times 2 gives you 6 oxygens. With the wrong thing. 6 oxygens. And then, by the way, while you're at it, it also changed my manganese. How many manganese did it give me? 3. 3 times 1, that's 3. And then I'm trying to get 6 on the right-hand side because that's the common number. So what would you put right here to get 6 on the right-hand side? You'd have to put a 2, wouldn't you? All right. So because 2 times 3 makes 6. All right. Now, what else did that change? That 2. It also changed the aluminum, didn't it? So at 2, because it gives me now 2 times 2, it gives me 4 aluminums. Wow. We got oxygen okay. Yeah, oxygen looks fine. Oxygen 6 and 6. I like you, you're good. But everything else is messed up. Where do you want to go next? Doesn't matter. You can do it in any order you want. Let's go back to manganese. Why not? 3 on the left, only 1 on the right. I'm going to put something here to get manganese to balance. 3 on the left. How do you get 3 on the right? You need to put a 3 here. Because then it would be like 3 times 1. It applies till you get to the plus sign. So it's 3. All right. And then, oh, we're almost done. What do we need next? We got to balance aluminum. 4 on the right. How would I get 4 on the left? Oh, I need to put a 4 right here, wouldn't I? Because that would give me 4. Okay. So I think now we're balanced. All right, so, this is again one of these topics where you just got to take it step by step and you get a little practice. Hopefully it'll make more sense, right? You got to practice this a little bit. Okay, so let's go ahead and move on. And we're going to do a couple that are a little bit more challenging. So how can this get a little bit more challenging? Well, let me tell you. All right, one way you can get a little bit more challenging is that what if I don't give you the formulas? I give you the names of what we're using. So if you're starting off with the names of these compounds, sodium oxide reacts with chromium 3 nitrate to turn into sodium nitrate and chromium chloride. If you see this, before you can even try to balance this thing, you've got to come up with the formulas. So in this example, we're going to have to go way back. Well, not that way back. We're going to have to go back a little bit to how we write formulas. So remember how I told you knowing how to write formulas is important? Yeah, it keeps coming up, doesn't it? So you are going to have to write the formulas. So I'm going to write a little note over here. So you're going to do formulas first. So that's like the old stuff we learned. So you might have to use charges, or I don't know. You might have to use like the prefixes, all that old stuff that you learned a while ago, a couple weeks ago. And then once you get the formulas right, then what we're going to do is balance the reaction. So the way that this gets a little bit more complicated is if I tell you the formulas, you got to go back and come up with the formulas. All right? If I tell you the names, I mean. You have to come up with the formulas. So I'm going to go through this, and I might go through this a little quick. If it's going a little fast, you can always pause and rewind it or watch it again. But this is just like what you did earlier. So don't even worry for right now that it's in a reaction. Just pretend I said, hey, we got sodium chloride. What the heck is the formula for sodium chloride? Let's write that out. So all that stuff we talked about still applies. +1 column, +2 column, -1 column, -2 column, etc. All these weird guys in the middle, 3 and 2 and 1, all that still applies, right? So what's the formula for sodium chloride? Oh, what's the symbol for sodium? Na. Find it on the periodic table. +1. Chloride. What's chloride? Cl. What's this charge? -1. The formula for sodium chloride, do we need any more of anything? I don't think so. 1 and 1 balances. NaCl. All right. Don't even worry about a reaction yet. Let's move on to the second one. If I just said, hey man, can you tell me the formula of chromium 3 nitrate? All right, we're going to do the same thing. You got to know, how did we write formulas? Write the symbol in the charge of the first thing. Chromium. What's the symbol for chromium? Do you remember that one? It's Cr. It's right here, Cr. And remember, the Roman numeral is the charge. Oop, I'm going to write it up here, I should say. And then we get to nitrate, chromium 3. That's what the chromium 3 is. Nitrate. nitrate 8,8. Polyatomic right here. NO3 minus 1. Now you got to balance out those charges, don't you? So what are you going to write? Cr NO3 3. All right, that's the right formula. You need 3 nitrates. All right, let's keep going. Same thing on the right-hand side. Just tell me the formula of sodium nitrate. So that's all you got to do so far. Just write the formula. All right, same thing we learned before. Look at those charges. So sodium is Na, right? It's still plus 1. Yeah. And then it's hooked up with nitrate 8888, that polyatomic. Sodium nitrate is NO3 minus 1. All right. Hey man, what's the formula for sodium nitrate? I'm hoping you're going to tell me, oh, that actually works out. We don't need any subscripts. It's just NaNO3. Should look like that. All right. Now what about the last one? Oh, do you know what? I left out something here. It should be chromium 3 chloride. I left out writing the 3, didn't I? Sorry about that. All right. What's the formula for chromium 3 chloride? All right. I'm going to take a little pause. Can you figure that one out? What's the formula for chromium 3 chloride? Oh, I hope you know it is CrCl3. How did I come up with that? Chromium is Cr and 3, chromium 3, chloride right here, minus 1. So when you put them together, you need 3 chlorides, don't you? So it would be CrCl3. All right, so at this point, we've got all the formulas correct. So you got to worry about charges. You got to worry about getting the charges to balance, all that stuff, right? So now that we have the formulas right, now we're going to move on and balance the reaction. Now I have to say, I probably don't have any room on this one. So let me go ahead and move on to the next page, and I'm going to try to balance this thing. So I'm going to go to the next page and rewrite it, okay? So get your formulas right, and then balance. Let's do the balancing part now. Okay, so to do the formulas, oh, we already wrote them, didn't we? So I'm just going to rewrite them. NaCl, Cr, NO3, 3 turns into NaNO3. And oh, remember, there should have been a 3 here. My apologies. Chromium 3 chloride. Beautiful. All the formulas right. Now that we got the formulas right, we're going to go back and we got to get the atoms on both sides to match up. So this is called balancing. All right, so to balance, we're going to put in coefficients right here. All right, now let's go ahead and make our list here. All right, I've been doing this a few times, so again, I might go a little faster. If it's too fast, please just rewind and you can watch it again, or take, hit pause so you can think about it. All right, let's make our list. Sodium's on the left, 1 sodium. Chloride on the left, 1 chloride. On the left, 1 chromium. On the left, okay, I see nitrate and I see it on both sides, so let's keep it as a group. It's a polyatomic, and I see the same polyatomic on both sides, so let's just think of it as a group. 3 nitrates. On the right, let's do that. Sodium's 1 of them. Now, again, this is sort of my nitrate here, right? Hopefully this isn't making it more confusing. So there's really just 1 of those nitrate units. All right. So again, if it helps you, you could kind of think of it sort of like in parentheses. We don't usually put it in parentheses because there's only 1 of them, but just to make sure you're clear that, yeah, that's a nitrate. Now, also on the right, there's a chromium, and there are 3 chlorides. All right. So there's a couple issues we're going to have to fix. Let's just go down the list. Sodium seems A-okay. All right. So the first one I notice is chloride. So to fix chloride, we are going to need to put a number. We are going to need to put a number right here in that first blank. What number do you need to put in that blank to fix chloride? Oh, I hope you know it's a 3. You need to put a 3 here because now it triples that entire formula. It gives me 3 sodiums. And it gives me, because 3 times 1 is 3. And then it gives me 3 chlorides. 3 times 1 is 3 chlorides. It should look like that. All right. So with that, chloride is good. Oh, chloride's matching up. Do you know what, though? We kind of broke sodium, didn't we? Ugh, that sometimes happens. So sodium now seems out of balance. So let's go back and let's fix sodium. With that 3 here, with this 3 right here, that gave me 3 sodiums, yet there only seems to be 1 on the right. So I'm going to stick another number right here to get sodium back to being okay. What number goes right there? Oh, I hope you know it should have been a 3. All right. So to balance it, you need a 3 there. Oh, does that work? I think so. It triples everything in that formula. 3 sodiums. And also, it would be like 3 nitrates. Oh, do you know what? That's actually good because we needed 3 nitrates. So everything is matching up. We're balanced. All right, so yeah, you needed a 3 in the first blank and a 3 in the last blank. Okay, all right, with that, oh, what kind of reaction is this? Double replacement. Double switch thing going on, isn't it? Double switch thing. This is a double replacement. Okay, let's move on, and we'll do one more like this where we start off with words, and you got to take the words and turn them into formulas first. Let's try another one. All right, one last example today. All right, one more example along the same lines. We got some words. We're going to have to turn them into formulas, and then we can balance the reaction. So apparently in this one, we went and grabbed some calcium chlorate, and it reacted, I don't know, blew up. Maybe it wasn't even on the other side. Something happened. And then after it was done, after the reaction was over, we made calcium chloride, and we also made oxygen. Okay, so calcium chlorate turns into calcium chloride and oxygen. All right, before we can do anything else, we got to write the formulas. Calcium chlorate. Oh, let me remind you. +1, +2, all those charges. Oh, yeah, you got to worry about those charges, my friend. Yes. All right, there's more of them. I'm just going to kind of put in the main ones for now. Okay, calcium chlorate. Calcium, what's the symbol for calcium? Ca. And what's the charge on it? Right here, +2, isn't it? Chlorate. Calcium chlorate. 8. Chlorate is right here. It's a polyatomic, right? If it ends in 8, it should be on that handout. So chlorate would be ClO3 - 1. All right, so the formula, if I just say, can you tell me the calcium formula for calcium chlorate? I hope you would tell me, oh, we started off with, apparently, ClO3. Oh, what else do we need? Parenthesis 2. That's the formula for calcium chlorate. You got to write formulas. All right, it reacted. Something happened. I don't know. Something made it react. It turned into calcium chloride. Can you tell me the formula for calcium chloride? All right, you got to do the same thing. Calcium +2. Chloride. If it says chloride, that is an element, right? IDEs are on the periodic table. So I'm talking about this fella right here. And that fella is also -1, it turns out. So the formula would be, what would it be? It would be calcium chloride. Hey, tell me the formula for calcium chloride. CaCl2. All right. Plus, we also somehow made oxygen. What the heck is the formula for oxygen? O? Or when should I be writing O2? Which one is it? Do you write O or do you write O2? Oh, it's one of those 7. Oh my God, there's a lot to remember. It's one of those 7. It's O2. All right, so those are all my formulas. All right. So after we write the formulas, then we can go back and balance the reaction. So formulas have to do with charges. Formulas have to do with all that stuff that we talked about a week or 10 days ago or something, right? Charges, subscripts, all that. Got the formulas right. Now let's get the atoms to match up on both sides. So let me go ahead and do that. I'm going to flip to another page. And we already came up with the formulas. Let me just write them out again. That's a parenthesis there. Darn it. Hopefully you can tell that's a parenthesis. Turns into this and this. All right. So I'm going to make my list here, and we're going to see where we need some coefficients, right? So now we got to get the same number of atoms on both sides. All right, let's do it. So to get the same number of atoms on both sides, we got to know how many we're starting with. How many calciums are on the left? One, right? There's just this one right here. And you know, I just don't like this. I'm going to erase this. I'm sorry. Let's make this a little more clear. There we go. And now, ClO3 is actually a polyatomic. And I want to point out something to you, though. Remember I said, hey, polyatomics, just think of them as a group. But I've also said you can only think of them as a group if you have the group that shows up on both sides. So you might notice in this reaction, the chlorate, I'm talking about the ClO3, I see it on the left, but I do not see it on the right. So in this reaction, the chlorate kind of got messed with. It's not there anymore. It got changed. So you can't just list it as ClO3 because you don't see it on both sides. So what does that mean? It means when I make my list, I need to go atom by atom. We can't treat the polyatomic as a group. Oh, that's sad. It's going to take a little longer. All right, so let's go ahead and make our list, though. Chlorides. If I asked you about the atom Cl, how many are on the left? Oh, there's a parenthesis. Oh, there should be 2, right? Because 2 times 1. And then how about how many oxygens? Oh, there's a parenthesis. 6 oxygens. All right, now let's see what we got on the right. 1 calcium, 2 chlorides, 2 oxygens. There's my list. All right, you know what? This one isn't going to be too hard to balance. You only need to put in one number. Where does the number go? First blank, second blank, or third blank? Which one is going to need a number? Which blank? Think about it. Okay, I hope you know it's the third blank. You need to put a number right here. What number goes right there to balance this thing? Oh, I hope you know it's a 3. All right, and now it's balanced because 3 times 2 makes 6. I hope that made sense. Oh, if not, we'll practice some more. Okay, so now it's balanced. Okay, so we've taken, whatever that word is. How would I know this? I'm American English. I should know this stuff, right? We've taken, there we go, the words, we made them into formulas, and then we got the number of atoms on both sides to match up. So we're in good shape. Oh, last thing, what kind of reaction is this? One thing is breaking into 2 things. That's decomposition. It's a decomposition reaction. All right, I'm just going to clean this up a little bit so you can see if you want to, like, what is this supposed to look like? That's what it would look like. Okay, so it's a decomposition reaction. All right, with that, that's kind of it for this lecture, lecture 15. I'm hoping it's making sense. If not, hey, you can always contact me. Hey, we got Zoom times to do some more practice, get better at this. With that, we'll stop, and I will talk to you in our next lecture soon. All right, bye-bye for now.